All right, everybody, welcome to another lecture on linked lists. Today we're going to just talk about the insert function with a sort order. Okay, so again, this isn't critical for the lab, for the exam, but I do want to talk through it. I do want you to see the code, and hopefully, if anything else, it just helps to gain a better understanding of how this insert function is working, and just how we can manipulate our linked list, how we can manipulate those pointers, because our linked list is just simply a series of pointers to those nodes. So we'll take a look at that, and then we'll wrap up, and then I'll just provide one more really short lecture on how to delete. And we don't really need to delete anything for the lab or for the exam, for the final exam or anything, but it's just good to talk through it so that you can see how relatively straightforward it is. As far as the code then, what you'll see here is this is exactly the same as the code that we left off with. Okay, so we don't have to make any changes to our main function other than maybe the values that we're going to insert. Just a note on this insert function, you can call this as many times as you want. So let's say that I want to do insert another node. Okay, doesn't really matter, we just have to call it as many times as we want. Print list function is the same. What I did then was I created a block level comment to get rid of our original insert function, and then just uncommented the next version. As far as this version goes, this is going to maintain a sort order. And right now it's going to be an alphabetical ascending, so A, B, C, D, E. So anytime we call an insert here, even though we call this now, when we run this code, you'll see that it's CAF, it'll print off as ACF. Okay, it will print this off in the correct order. It'll create this in the correct order regardless of what order I insert these nodes. When we look at this insert function, okay, the arguments are the same, and for the most part, a good chunk of this function is identical. Okay, we still have our 3 pointers. We still need to walk the linked list. The main difference is when do we stop walking? Because in the previous version, the previous insert version, we just walked to the end, added a new node to the end, linked that new node to the end. But now we're not doing that. Now we're just walking until we find where alphabetically the node or the char that we're trying to insert goes. Okay, so we have our 3 pointers to help us do that. We malloc memory for the new node, the node that we're creating. Make sure it's not equal to null. Update its values. So the value that we're inserting, its next node member is equal to null. And we do this because at this point in time, we don't know where it's going to go. So we want to set it equal to null just for good variable member initialization. Okay, previous pointer, we set that equal to null, and our current pointer is equal to the start pointer. So again, we don't know where we're going to insert this node, but so we're going to start at the very beginning. Our first big change comes when we look at the while loop. We have a condition. Okay, current pointer is not equal to null. That's the same thing. This helps us to walk to the very end. If we are just going to insert a node at the end of the linked list, then this condition still helps us find that. The second condition then is the difference, and this helps us to identify where we need to insert a node in between, anywhere in the linked list besides the end. Okay, I'm going to talk through some of this here in just a minute. Inside of here, you'll see exact same structure, and then finally, once the loop breaks, okay, regardless of how we get there, once the loop breaks, then we know that we found the correct position. Okay, previous pointer and current pointer, and it needs to go in between there essentially. And we have 2 branches of logic here, our if and our else branch, and this will help us to determine exactly how we need to set this up. And we'll talk about all through this here in just a sec. So what does this condition do? Big picture, what we're looking at is ASCII values, right? We've got a linked list with data members that are chars, and we know at the core a char is just an integer value represents the ASCII table. If we go back and take a look at the ASCII table, we know that the numeric value for a lowercase a is 97. And we use this then in this condition, right? I said that this is going to insert nodes in alphabetical ascending. So let's say right now that we have a linked list. And in the linked list, we have a value B, and we have a value, let's say F. Oh no, let's say C. Okay, that'll just make it easy. So if A is 97, that means B has a numeric value of 98, and C has a numeric value of 99. So I want to insert A, but I want to do it with a sort order. What does this condition help me do? Well, it says that while value is greater than the current data member of the node I'm looking at, so the current char. Well, as long as it's greater than, I want to keep going, because A has a smaller numeric value. So anything with a smaller numeric value comes before anything with a greater. That's how we maintain the sort order. So in this example, A is 97. Is our current pointer not equal to null? That's probably true. It has to be true. Is the value greater than current pointer's data member? So is 97 greater than 98? It's not. And so then our loop will break, and we'll be able to determine here when we look at the if-else branch how to set up our linked list with a new root node. This would become a new root node, okay? Simply by using the numeric values. Okay, so let's say then that we have a different setup. Let's say we have A, we know that's 97, and we have C, and that equals 99. And now I want to insert B. Okay, we know B has a value of 98. So what do? Well, we'll have one iteration through our loop. We'll do just like we did in the print list. We'll start walking the nodes. So the first test we'll say is 98 greater than 97. Okay, this first condition will be true because we're walking the linked list. We know we have a node. The second condition is also true. 98 is greater than 97. So we'll enter the while loop and we'll iterate. What's the next thing we do? Well, we compare the next node. Here's our first node, here's our second node. The value of our second node is 99. It's a lowercase c. So we compare. Is 98 greater than 99? It's not. Okay, so now we break. We don't enter into this loop again and we break. What's the condition of our pointers? Well, current pointer is going to be pointing here, and previous pointer will be pointing at the previous node. Okay, so the logic stays the same. It's just how do we break it? And the big thing on this one is that current pointer might not always have a null value. Okay, it just depends on where we break in the linked list. All right, so that's how we're going to use that second condition and the numeric values of a char to simply determine in conjunction with this other condition. Remember, logical end, both of these statements have to be true in order to iterate. Every time we iterate, we walk to the next node. When we need to stop walking nodes, one of these conditions will be false, and we'll break. And now we'll look at that if-else branch here in just a second. So this is how we're going to use those numeric values to determine where we need to stop in our code. Go ahead and discard that. Okay, so here is the next branch. So once this loop breaks, we know the node that we need to insert. We know the two nodes that we need to insert. There's kind of three places that we need to be concerned about. One is we're just inserting it at the very end, okay, and then the logic really doesn't change at all. The next one is that we're inserting it between two different nodes, and again, the logic doesn't really change here. The special case, and what we're gonna handle with this if branch is, what if we're creating a new root node? Okay, so this loop breaks. We'll have value for previous pointer. We'll have a value for current pointer. First thing we do is we check, is previous pointer equal to null? Okay, when would previous pointer be equal to null? Well, if we go back and look at our code here, this is about the only time previous pointer is equal to null. When do we set this up? We set this up with the very first iteration of this loop. So if previous pointer equals to null, that means current pointer was not equal to null. That means that we never entered this loop. Okay, previous pointer maintained a new null, or maintained a null value. That means that we have a new root node. So we have to shift things around a little bit. We say that our new pointer's next node equals the start pointer, and the start pointer equals the new pointer. Okay, new pointer, if this is the new root node, then we have to link it to the existing linked list. What represents the linked list at this point in time? Our start pointer. Okay, that's the argument. The value that we pass into there from our main function is the memory address of that root node. Okay, so what that gives us then is that says our new pointer's next node member is no longer equal to null. It equals the beginning of the linked list. This is now the new root node. But in order to update the program needs to know this. So pass by reference. So we have to set the start pointer equal to the new pointer's value as well. Okay, so that when this function returns, when this code executes, and then this function ends, it terminates, it returns, then this line right here ensures that this pointer has its memory address updated as well. Okay, because this is all kind of a global. This is all pointing to one place in memory. So when we update that memory, our root node now points there as well. So let's see if I can help us walk through some of that code. So what I'm going to do is I'm going to grab a screen capture of that, and we'll paste it into here, just so we have something to look at. Right. Here, I'm just going to get rid of the comments. All we care about is the code here. Okay, and then I'll make that a little bit larger. All right, here we go. Okay, so if we go back to the first example we talked about, I said, what if we want to, we have a linked list, we have a value of B, we have a value of C, and here, let me actually change my diagramming just a little bit. And let's say that we have value of B and we have a value of C. So our current linked list looks like this, and this guy here points to a null value, right? And we come along with this new function and we want to insert A. So here's our node, we've allocated memory for it, and right now it points to a null value. So we enter into our code, we set it up as we just talked about, and then we hit the first while loop. We already hit this while loop. Say if we have our new pointer, okay, and that equals whatever memory address was assigned here, and then just like our previous, we have our current pointer and we have our previous pointer. Okay, very first iteration, we initialize previous pointer equal to null, and our current pointer equals the memory address of our root node. Okay, so in this case, I'll just draw this, try to get it out of the way. It's pointing right there. Okay, so we test the condition. Current pointer is not equal to null. Okay, that's true, it's not equal to null. It's pointing to this node right here. And is the value greater than the current pointer's data member? Okay, so what we're doing is we're comparing A, which was 97, is that greater than B, which is 99? That's not true. Okay, so this condition is not true. So we don't even iterate. We don't even go into that branch of code. So we move past the loop, and now we execute this if block. Okay, we test the condition first. Is previous pointer equal to null? Well, we know right here, previous pointer is equal to null. We didn't iterate. We didn't enter the loop. We didn't have an iteration. We didn't update its value. So now we say new pointer's next node member equals our start pointer. Okay. So let's just add that here, start pointer, that's our argument to this function, and it's pointing to the exact same location as our current pointer. We made that assignment in the code, and now we set new pointer's next node member equal to start pointer. Okay, here's our new pointer, its next node member pointing to null. We're going to update that, and it's going to point right here. Okay, and now start pointer is equal to new pointer. Okay, so here's our start pointer, and it was pointing at what was previously the root node of our linked list, but we're going to change that. We're going to get rid of that, and we're going to say our start pointer now points right here. Boy, okay, so that looks a little ugly, but that's what these two lines of code. Okay, this is our new node. It's now linked to the beginning of our linked list, and our start pointer now points to that new node, the memory address there. Because we linked it, when we start with this memory address, we have the ability to iterate over every single node in the linked list. All right. So the else branch, and the else branch does everything else. Okay, this branch right here is only for when we have a new root node, and this is the process that we need to take. Everything else, the else branch handles everything else. That means we have to insert between two nodes, or we have a new end of our linked list. So we won't cover the end of the linked list because we've already covered that in the previous insert function and even the print list function to a large degree. But we will walk through the everything else. Okay, so this is recorded. If you need to go back and take a look at all these annotations, hopefully they helped. Hopefully they make sense and they're clear. Ooh, I do want to keep those. And you can just rewind and pause on those. We have our new pointer, our current pointer, our previous pointer, and then our start pointer. Okay. So when we're talking through this, I'm going to include that argument, that function argument, because it's important that we have it. Current pointer is start pointer. Okay, so let's say this time we have some nodes. We have a linked list already, and the current linked list is going to be A and C. Okay, we know there's some memory address for the root node, so I'll identify this as root, and it's going to point right here. And this is going to point or have a null value. So now I want to insert a new node, and that new node is going to be B. Okay, and right now its next node member is equal to null as well. So our new pointer is pointing to this memory address. Our current pointer is going to point to start pointer, and start pointer is pointing right here, right? So current pointer is going to point right here as well. And I'm just going to draw it kind of through the middle there to hopefully save a little bit of space. And previous pointer, okay, previous pointer right here is still equal to null. So we check our loop. Current pointer is not equal to null. That's true. We're pointing at a node. And the value is greater than current pointer's data member. So what are the two values that we're comparing right now? Well, we're comparing value, which is B. It's the value that we want to insert. We know that that's equal to 98. Is it greater than the current pointer, the current node's data member? That node has a value of A. That's 97. That's true. Okay, so we iterate. We enter into that loop and we adjust. We say previous pointer is equal to current pointer. Okay, so here's our previous pointer. It's no longer equal to a null value. It's going to point to our root node. That will become the previous node that we looked at. And our current pointer is going to move. We're going to iterate to the next node. So it's going to point right here to the second node. Okay, now we've executed both lines of this loop. We're going to loop around. We're going to check the condition again. Is our current pointer equal to null? Not equal to null. That's true. It's not equal to null. It's pointing to the second node. Now we have the second condition. Is the value that we're trying to insert greater than the current node's data member? Well, our value is B, which is 98. C is 99. Is 98 greater than 99? That's not true. That's false. Okay, so we don't enter this loop. This condition breaks, and now execution passes. Execution passes to our if-else branch. All right, so first thing we need to check. Well, hold on. Before we do that, I'll just make sure we're clear on where our pointers are pointing. So new pointer is still pointing to the node that we just created. Current pointer is pointing to the second node, and previous pointer is pointing to the first node. Okay, and then start pointer is still pointing to the beginning. So I guess I could add yet one more arrow into here for that. Okay, start pointer is always going to point to the very beginning of this linked list. Okay, so we've checked this condition first. Is previous pointer equal to null? Previous pointer is not equal to null because we're pointing at this node that has a value of A. So we go down the else branch. New pointer, next node member equals the current pointer. Okay, we've identified in our code that this is where we need to insert. In order to maintain this alphabetical order, this is where we need to insert this new node. So we need to link the root node to the new node and the new node to the C node. So we say new pointer's next node member equals current pointer. Okay, so here's our new node, and its member is no longer going to have a null value. It's going to point to this value right here. Okay, and I know this is terribly ugly. I wish we could figure out a better way to do this. Hopefully it's clear enough. Okay, so this line of code updates our new node's next node member to the current node. Okay, so that's what we're setting it there. We need to get it in between these two nodes. Our next line of code, right here, we're going to say the previous pointer's next node member equals the new pointer. So if we take a look at the previous pointer, okay, previous pointer we know is pointing to this node here. Right now it's linked to that next node, the C node. We need to change that. So we need to remove that link, and now it needs to point to our new node. Okay. And now, to get rid of some of these lines here that hopefully clear this up, You don't need to look at start pointer. This is ultimately what we have done. Okay, we've identified in our code that if we have a node, a linked list with an A and a C, and we want to insert B, that we've identified which two nodes we need to insert in between. We've used our loop to do that, the condition of our loop. And now with this else branch, we've taken that previous node. Okay, it doesn't matter if this is the root node, it's the previous node. We need to insert it in between two nodes. So we've said the previous node now links to our new node, and our new node now links to the current node, and then the current node, this would link to whatever. Okay, in this case, because this is only going to have 3 items, 3 nodes in this linked list, this will continue to link to null. If this linked list had 50 items, you would see here that all we had to do was change what does this link to, what does the previous node link to, and what does the new node link to. And now we could cleanly insert that into this linked list, and we wouldn't have to shuffle every single node around. Okay, so hopefully I was able to add some clarity with this, with my drawings here. I know it's hard to draw on these tablets, but if this doesn't make any sense, if there's any part of this that I said that just isn't clear, let me know, and I will help either walk you through it, or I can produce another lecture in which I will try something different. So that's really it. Let's see if we. Let's go ahead and change the code here. Okay, so CAF. If we run that, we know that when we create C and then we create A, we know because this is going to force us to create a new root node. We know that that'll test our logic here. It'll test the loop, and then it'll test this branch. Then once we've inserted the A, we insert an F. We know this is going to go at the very end. So we know that, again, it'll test our loop, and then it'll test this else branch. So if everything runs correctly, we'll see ACF is our output. Oh, and it helps if you save your file. So we'll try that one more time, compile it, and we'll run it. And there we go, ACF. Right? So once this prints this root node, remember we updated the root node. When we insert A is a new root node. So that's why we pass that as a pointer, and we update that value. We update what that is pointing to, that memory location, to a new address. All right, so again, just keep in mind as you go through the insert function, it can be a little confusing until you've worked through it. Walk through it on paper, that'll help if you're not comfortable with the code anyway. But just keep in mind, you do not need to worry about this for reversing for the lab, to reverse a linked list. You don't need to do that. You're not worried about sort order. You're just simply worried about reversing it. And we'll talk about here in the next lecture, deleting, and then we'll go through and I'll set up what you need to know to get through the lab. So, all right, any questions, let me know. Otherwise, thanks, and I'll see you in the next lecture.